In lesson 9 of Structure and Bonding topic 2, we will again be learning about cells, batteries, and in particular hydrogen fuel cells. Before that though, here's a quick quiz to test you out on last lesson and also some questions from earlier in the topic. So pause the video and think of your answer for each one. Is it true or false? Pause it now. Here we go with the answers. Number 1 is false. Cells need to be connected in series to make a battery. Number 2 is true. Number 3, the two metals placed into an electrolyte, need to be different metals to each other. Rechargeable batteries make use of reversible chemical reactions is true. Number 5 was true. Number 6 was true. Number 7, group 1 metals have lower density than other metals. Number 8 was true. Number 9, positive ions are formed when atoms lose electrons, and coarse particles are larger than fine particles, and both of them are larger than nanoparticles. Okay, here we go. Today's driving question: how does a hydrogen fuel cell work? We're going to be looking in detail at the reactions which take place inside a hydrogen fuel cell. Now, hydrogen makes a good fuel. It used to be used in space shuttles, still used in rockets, and hydrogen reacts together with oxygen to release energy. It's a very exothermic reaction. Right, I'm just going to skip over these. And yeah, when hydrogen and oxygen react together, a large amount of energy is released, and the only product is H2O, water. So it potentially makes a very good fuel because it releases a lot of energy and it doesn't produce pollution, unlike hydrocarbons. Water is the only product. Right, now, pause the video and think of what would the word equation be for the reaction inside a rocket using hydrogen fuel. Pause it now and think of your answer. Let's have a look. It is hydrogen plus oxygen, arrow, water. It's an exothermic reaction, but we don't write energy into word equations. We just write the reactants and products. Hydrogen plus oxygen makes water. What would the balanced symbol equation be? Pause the video once again and see if you can write down a balanced symbol equation for hydrogen reacting with oxygen to form water. Pause it now. Right, let's have a look. Hydrogen is H2. This is unbalanced, by the way, as you can see. Oxygen is O2, water is H2O. Let's just go through how to balance an equation. Firstly, write down all of the atoms. And then I do a little line like this to help me separate reactants and products together. Right, so we've got 2 hydrogens, 2 oxygens, and then on this side, 2 hydrogens and 1 oxygen. There's not enough oxygens on this side. Now, I can't change the chemical formula to H2O2. That's a completely different chemical. That's hydrogen peroxide. We can't change little numbers. Instead, we put a large number in front of H2O. And we then need to write down all the atoms that gives us. That's now 2 lots of H2O. So that means 4 H's and 2 O's altogether. So now the oxygens are balanced, 2 on each side, but there's not enough hydrogens on this side. We can't change the small numbers, can't write H4, that would be a totally different chemical. So instead we take 2 lots of a chemical, and that then creates 4 H atoms on this side. This is the reaction that would happen in real life. Atoms cannot appear or disappear, so the atoms in the reactants have to be the same as the atoms in the products. So the balanced equation is 2 lots of H2 gas reacts with O2 gas to form 2 lots of H2O. That is the overall reaction which takes place when hydrogen reacts with oxygen to make water. Now we can make use of this, not just for rockets, but also for hydrogen fuel cells. But the reaction works in a different way, and it's much more like the cells we were looking at over the last couple of lessons. And hydrogen fuel cells can be used for powering large objects like cars and trains. Oh, I've got a little video clip of a hydrogen train. Don't remember. Let's have a look. This train is not diesel, not electric, hydrogen gas. Although sometimes it's compressed to form a liquid. So they sometimes run on liquid hydrogen. That's done through pressure by compressing the gas to form a liquid. What else have we got? Buses can be run on hydrogen fuel cells. They produce enough power to be used in cars, buses, and trains. Now let's have a look at how the cell is constructed. There are 2 halves to the cell. Like any battery, it has a negative terminal and a positive terminal. Okay, so when you look at an AA battery, it'll say negative on one side, positive on the other. When you use a power pack, negative on one side, positive on the other. This is a feature of all cells and all batteries. The two halves are separated though, and there are two separate reactions which takes place. We're going to look at the left-hand side first, and then we'll look at the right-hand side, the positive side, afterwards. Now, electrons flow from the negative side to the positive side. So you can measure the voltage of that with a voltmeter, or you could connect it to the circuits of a car. The engine inside there would be run on the electricity. So it's the flow of electrons which powers an electric motor. Right, let's start looking at these reactions. There's quite a lot of detail. Right, on the negative side, the left-hand side of this diagram, hydrogen gas goes in, water comes out. Right, now it's not actually reacting directly with oxygen. Instead, there are ions in the electrolyte, which we'll get to in a moment. On the other side, oxygen goes in and water comes out, right? And we get a flow of electrons around the circuit from the negative side, electrons flowing round to the positive side. We're going to look in detail at the two halves of a hydrogen fuel cell. Right, so let's go for it. Right, so on the left-hand side, the negative terminal, hydrogen goes in, water comes out, but it's not reacting directly with oxygen. Oxygen is on the other side of the fuel cell. So what's happening on the left-hand side? Well, the electrolyte contains ions, H plus and OH minus. Now, on the left-hand side of this hydrogen fuel cell, it's the OH minus ions that are going to react. So hydrogen gas actually reacts with hydroxide, OH minus. That forms water and also produces a flow of electrons. Okay, so hydrogen reacts with the OH minus ions from the electrode to produce water and electrons. Okay, right, yeah, so let's show that again. So hydrogen gas goes in, it reacts with the OH minus from the electrolyte, water is made, and electrons are produced. Now, can you summarize that in your own words? You don't have to write it down, think it to yourself. What is reacting and what is being produced? Pause the video, try and put it in a sentence. What reaction is actually taking place on the left-hand side, the negative side of a hydrogen fuel cell? Pause it now. Let's go through it. Hydrogen is reacting with OH minus ions from the electrolyte. Okay, so the hydrogen actually reacts with OH minus. Water is produced and a flow of electrons is produced. So on the negative terminal, hydrogen reacts with OH minus to produce water and electrons. Let's have a, oh no, we're going to do the equation first. Right, before we move on to the right-hand side, we need to look at the equation. Right, hydrogen and OH minus react to make water and electrons. So this is representing the same thing in a simple equation. We are going to run through how to write this balanced equation. Let's have a look at that now. Right, so here's the unbalanced equation. Hydrogen is reacting with OH minus to make water and electrons. Now, I always use the same technique for balancing equations, and that is to write out the atoms underneath. Just in rough work, I just, if I'm doing an exam, I scribble it in the margin or wherever, underneath the reaction or wherever I can. But in this case, because we've got minus on this ion, I've written down the minus as well, because the charge needs balancing as well as the atoms. An electron has a negative charge, so I've written minus down to represent that. Now let's have a look. 2 hydrogens on this side, no, 3 altogether. 3 hydrogens on this side, 2 on that side. That is not balanced. There need to be more hydrogens on the right-hand side. So I'm going to put 2 in front of H2O. But that gives me 2 of the whole chemical. Okay, so now I've got the right number of hydrogens. Well, I've got too many now on this side, 4 hydrogens on this side. I'm going to need more on this side. Right, now if I put a 2 there, that gives me 2 OHs and another 2 minuses. Okay, so I've now got 4 hydrogens, 2 oxygens, 2 oxygens. Good, that's all fine. But I've got 2 negative charges on this side now. I'm going to need 2 negative charges on the right-hand side. So I need to put 2 in front of that electron. That is now the balanced equation. We need to balance the atoms, but also balance the charges, because OH minus has that minus charge on it, and the electron also has a minus charge on it. So that is now the balanced equation for the negative terminal, the negative side of a hydrogen fuel cell. Hydrogen reacts with OH- ions from the electrolyte to make water and electrons. Right, which is correctly balanced? Pause the video, read them through, which is the right one. Check the state symbols as well as the balancing, which is the correct equation. Pause it now. Let's move this on to the answers. It was A. A is the correctly balanced equation. Note that hydrogen is a gas. Hydroxide, the ions are dissolved, AQ. Water is a liquid, and then electrons don't need a state symbol because they're not solid, liquid, gas, or dissolved. Okay, it is time to look at the other side of the hydrogen fuel cell. Hydrogen on the left, negative side, hydrogen goes in, OH- reacts with it, water comes out, and so do electrons. Okay, so we've covered that now. Now the electrons flow round to the other side of the fuel cell. They're going to flow round to the right-hand side. So let's have a look at what's happening on the positive side. So the electrons are going to flow in from the negative side to the positive side, and oxygen is going in. Okay. Now the electrolyte, as we said before, contains H plus and OH minus, and it's the H plus ions that react on this side. H plus reacts with O2 and the electrons from the circuit, and those three things combine together to make water. So oxygen and H plus and electrons react together to make water. Okay, that is what is happening on the right hand side. Oxygen reacts with the H plus and the electrons to make water. Right, can you put that into your own words? What reaction is happening on the positive side of a fuel cell? Pause the video, and what are the reactants and products? Pause it now. Okay, let's take a look. Oxygen reacts with electrons and H plus, only water is produced. Now, let's look at the equation. Oxygen and H plus ions and electrons react together to make water. Okay, we're going to go through how to balance this equation as well. So here we have oxygen and H plus ions and electrons reacting together. Let's write out the atoms, but also the charges. Right, so this time we've got a plus charge here and a negative charge. If pluses and minuses are on the same side of an equation, then they balance out. So one plus will balance one minus. So it is actually balanced at the moment. But there's two oxygens on this side, only one on this side, and the hydrogens aren't balanced either. Right, where should we start? Let's put a 2 in front of water, and that gives 2 lots of H2O. That now balances the number of oxygens correctly, but we're going to need more hydrogens on the left-hand side. Putting a 4 in front of H plus provides four H's altogether, but also 4 plus charges. That then needs to be balanced by 4 negative charges, so 4 electrons are involved in the reaction. That's now balanced. Oxygen reacts with 4 lots of H plus and 4 electrons to make 2 lots of water. And that is the reaction which is taking place on the positive side of the hydrogen fuel cell. Right, pause the video. Which is the correct answer? Check the state symbols as well as the balancing. Pause it now. Here we go, let's take a look. It was C. Oxygen is a gas, the H plus ions are dissolved, the electrons don't have a state symbol, and water is a liquid, and it's got the correct balancing. Right, there's a lot of detail in those reactions. Let's summarise. On the right hand side, the positive terminal, oxygen goes in. It reacts with H plus ions and electrons. Water is produced. Now remember, the whole point of this is to produce that flow of electrons, electricity, which can then power an electric motor. Okay, so the positive side accepts electrons from the negative side, and it's that movement of electrons which makes a hydrogen fuel cell useful. So putting both sides together, on the negative side, electrons are given out. On the positive side, electrons are taken in. Right, negative side gives out electrons, the positive side takes in electrons. Now we can link this to the words Oilrig. A loss of electrons is oxidation. A gain of electrons is reduction. So the negative side, oxidation happens, and on the positive side, reduction happens. And the flow of electrons from one side to the other is what powers the car, or train, or bus. Okay, I'm just going to put all of this on one slide at the same time. If you get stuck during the written task, you can come back here and start looking up some of these informations. But if you have a look at the two equations that we've written down, the number of electrons on the two sides don't match, and they would match in real life. So what we sometimes do is double everything in this equation for the left-hand side. Okay, so we're going to do that now. If we double everything and make it 2, 4, 4, 4 instead, then both reactions have 4 electrons in them. So you might sometimes in a textbook or in an exam see it written down like this, 2, 4, 4, 4. But the reason for that is because in real life, 4 electrons would flow out of this side of the fuel cell and 4 electrons would be taken in by the other side. So they do need to balance each other in real life. Well, as I was saying, loss of electrons is called oxidation, OIL. Gain of electrons is called reduction, RIG. So this is also an oxidation reduction reaction, and we remember that through the acronym Oilrig. Oxidation is loss, reduction is gain. As I said, you can come back to this slide if you get stuck during your writing task. Now, just to prove what the overall reaction is, if we compare the two sides to each other, right, I've lined up the arrows here, and we've got the 4 electrons version in both cases. Actually, some of this cancels out. The electrons can cancel each other out. And the OH minuses and H pluses, 4H plus 4OH minus adds up to 4 lots of water. Let's take that out. What's left? 2H2 plus O2 makes 2H2O. This is exactly the same as the reaction we saw for the rocket at the beginning of the lesson. The overall reaction is hydrogen plus oxygen reacts to make water. But in order to create this flow of electrons, there are 2 separate reactions which happen, one on each side of the fuel cell. But the overall equation is actually quite simple. Hydrogen plus oxygen makes water. And now we've got the state symbols, gas, gas, liquid. Okay, right. So, yeah, the details of both sides of the fuel cell are complicated. So see how you get on with that in the writing task. And if you get stuck, you can always come back to the information earlier in the video. What's the correct overall equation for the reaction of hydrogen and oxygen? Pause it and choose A, B, C, or D. Let's have a look. It is B. 2 lots of H2 gas plus 1 lot of O2 gas makes 2 H2O liquid. That's the overall equation for hydrogen and oxygen reacting to make water. Right, yeah, lots of information on this slide. This might be a useful one if you get stuck on your writing task. So I'm not going to say it again, I'm just going to move over it now, but you can come back to this if you need to. And here's your writing task. The uses of hydrogen fuel cell, why are they beneficial? Think about the fact there's no pollution, they only give out water. And then starting to get into the details of these reactions, which is tricky. So here's some sentence starters. At green, we're looking for the overall reaction of hydrogen and oxygen. At yellow, we want to break that down into the negative side and the positive side and describe the reactants and products, what is actually taking place, then trying to write those equations and balance them. They're called half equations because each one shows half of the overall reaction. So pause the video, take as long as you need, and like I said, go back to an earlier slide if you need to because it is tricky, and then mark your answers after you've had a good go. Go for it, Year 10. Okay, I'm going to move this along to the answers slide. Please do tick and correct your work and add in anything you didn't think of. Let's go through it. Hydrogen fuel cells can be used to power cars, buses, trains. Space shuttle, I've put space shuttle there. I wouldn't say that was a fuel cell, it's more of a rocket. So hydrogen can be used in a space shuttle, but fuel cells are used to power cars, buses and trains. They're beneficial because the only product is water, so there's no pollution. They also give out a large amount of energy. And the overall reaction is that hydrogen is reacting with oxygen to form water, and there is the balance symbol equation for that. Let's move on to the details of the two sides of the fuel cells. At the negative terminal, hydrogen reacts with OH, and it produces electrons and water, right? Because it's producing electrons, it's a loss of electrons, that's called oxidation. Here's the half equation at the bottom of the screen, so you can check that. It's the doubled up version, 2444. Let's have a look at the positive terminal. Oxygen reacts with H+. Electrons are gained. So oxygen, H+, and electrons are reacting together. It only produces water. Because it's gaining electrons, it's called reduction. And here's the equation for that reduction, showing the gain of electrons down there. Okay, lots of tricky details there. Today I achieved describe, because I can describe the uses, explain the overall reaction. Today I achieved use, because I can summarize the changes happening on the negative and positive side. Today I achieved combine, because I can write the balanced half equations for the hydrogen fuel cell. Okay, well done for your effort in this lesson. This is actually the last new content, and lesson 10 is going to be a revision lesson, and that will be the end of the topic. So please do remember, there is a quiz for lesson 9. So go back to Show My Homework, click on the Show My Homework entry for Structure and Bonding 2 lesson 9, and complete the 10-question quiz to test you out on your understanding of today's lesson. Well done for your effort. Well done for keeping yourself going lesson after lesson. We're coming towards the end of this topic now, and I want to say a big well done for all your work so far. So next time, lesson 10 will be a revision lesson. See you then. Bye-bye.